You woke up this morning with your heart still racing from a dream you can barely explain. And part of you has been quietly wondering what it means about you. Your brain spent the night running scenarios you didn't ask for. Scientists have spent decades asking the same question you just did. And what they've found is almost the opposite of what most people expect. The research on nightmare function suggests something quietly radical. The frightening dream may be one of the most protective things your sleeping brain knows how to do. But here is the part that changes how you see it. The people who experience the most vivid, unsettling dreams are sometimes the ones whose brains are working hardest to protect them. Welcome to Sleepy Science Facts. Tonight begins with the question of what your sleeping mind is building, and why it builds it in the dark. Close your eyes. Breathe slowly. You are at the place where fear and safety are the same. Let your breath come. And now we begin. The word nightmare is centuries old, but the science behind it is surprisingly recent. For most of human history, bad dreams were interpreted as visitations, external forces entering the sleeper's mind from outside. It wasn't until the late 20th century that researchers began asking a different question entirely. Not what enters the dreaming brain, but what the dreaming brain is trying to do. The shift in framing changed everything. Rather than treating nightmares as things that happen to us, sleep scientists began examining them as processes the brain initiates, purposeful, structured, and biologically motivated. The nightmare, it turns out, may not be a failure of sleep. It may be sleep doing something specific. During a typical night, the human brain cycles through several stages of sleep, returning to the same stages in a predictable rhythm, roughly every 90 minutes. The stage most associated with vivid dreaming is called rapid eye movement sleep, or REM. During REM, the eyes move quickly beneath closed lids. The body becomes temporarily paralyzed from the neck down, and the brain produces electrical activity that looks remarkably similar to waking consciousness. Nightmares occur most frequently during REM sleep, particularly in the longer REM periods that happen in the second half of the night, the hours just before natural waking. This timing is not coincidence. It reflects something deliberate about how the sleeping brain sequences its work. The amygdala is an almond-shaped structure deep in the brain, one on each side, and it acts as the brain's primary threat detector. In waking life, the amygdala scans the environment constantly for signs of danger, activating the body's stress response when it finds something relevant. During REM sleep, the amygdala does not go quiet. Research shows it remains highly active, sometimes more active than it is during waking hours. This sustained activity during sleep is one of the reasons dreams carry emotional weight. The amygdala is not resting. It is working. And nightmares, in particular, appear to involve the amygdala in a state of concentrated, purposeful engagement. In the 1990s, a Finnish neuroscientist named Antti Revonsuo proposed what became known as the threat simulation theory. The theory offers an evolutionary explanation for why humans dream the way they do, and particularly why bad dreams exist at all. Revonsuo argued that dreaming, especially threatening dreaming, serves as a biological defense mechanism. The sleeping brain, in his model, uses the protected environment of sleep to simulate threatening events. Running through these scenarios rehearses the neural circuits needed to detect and respond to danger, sharpening the brain's threat response skills without exposing the body to actual risk. The nightmare, in this framework, is not a symptom. It is a training session. The threat simulation theory predicts that dreams should contain more threats than waking life does, and research supports this asymmetry. Studies analyzing dream diaries over decades consistently find that negative events in dreams outnumber positive ones by a significant margin, the reverse of what most people experience in their waking hours. This imbalance is not random. The dreaming mind preferentially recruits threatening material precisely because that is what the training requires. A simulation designed to prepare you for danger does not rehearse ordinary mornings. It rehearses the things that could go wrong, and it rehearses them with care. Threat simulations in dreams tend to follow a particular pattern. The dreaming self is almost always the target of the threat, not a passive observer watching something happen to someone else. Studies examining thousands of dream reports find that when threatening events appear, they are directed at the dreamer in the vast majority of cases. Revonsuo argues this specificity is important. A rehearsal that only practices reactions to threats aimed at other people would offer no survival benefit to the dreamer. The brain, it seems, understands this. It runs scenarios in which the dreamer is personally at risk, activating the specific neural pathways that would need to fire in a real emergency. The kinds of threats that appear most frequently in nightmares are not random. Across cultures and across history, certain categories of threat recur with striking consistency. Being chased is among the most universally reported nightmare themes. Being attacked, falling, finding oneself in danger in a familiar environment that has somehow become unsafe. These appear in dream reports gathered from populations separated by thousands of miles and thousands of years. Evolutionary researchers interpret this consistency as evidence of biological origin. These are not arbitrary fears. They are the fears that mattered most to the survival of human ancestors. Predation, falling from height, social danger, territorial threat. The dreaming brain appears to have inherited a threat library built long before language existed. Not all threatening dreams serve the same function. Researchers draw a distinction between bad dreams and nightmares. Bad dreams involve negative content and emotional distress, but do not necessarily wake the dreamer. Nightmares, by clinical definition, include an awakening. The dream becomes intense enough that it breaks the sleep state entirely. One theory suggests this distinction matters functionally. Bad dreams may complete their regulatory work without interruption. Nightmares, by contrast, may represent a kind of emergency override. The emotional content has become too intense for the brain's usual processing mechanisms to contain within sleep. So the system terminates the scenario and brings the dreamer back to conscious awareness. The prefrontal cortex is the brain region most associated with rational thinking, planning, emotional regulation, and the ability to put experiences in context. During waking life, it acts as a kind of moderating voice. It can receive signals from the amygdala and assess whether they warrant a full threat response. During REM sleep, the prefrontal cortex becomes significantly less active. This partial shutdown appears to be by design, with the prefrontal cortex quieter than usual. The amygdala is more free to process emotional material without being immediately dampened or reframed. The dreaming brain creates, in other words, conditions that allow emotional experiences to be felt and processed more fully, without the waking mind's habit of minimizing them. Something striking happens to the brain's chemistry during REM sleep. A neurochemical called norepinephrine, which is closely associated with the stress response, arousal, and the emotional intensity of fear, drops to some of its lowest levels of the entire day. This sharp reduction in norepinephrine during REM creates what one researcher described as a neurochemically safe environment. Emotional memories can be replayed and processed in a state where the stress chemistry that accompanied them the first time is turned down. The brain is doing something careful here, reviewing what frightened or disturbed you, while chemically reducing the sting of that review. Parna. It is, in a specific physiological sense, helping you process what happened. This discovery about norepinephrine and REM sleep came partly through an accidental observation. A physician at a Veterans Affairs hospital noticed that some patients taking a common blood pressure medication were reporting fewer trauma-related nightmares. The medication was prazosin, and its mechanism of action includes blocking norepinephrine receptors in the brain. What the accidental finding suggested was a connection between norepinephrine levels during sleep and the experience of nightmare intensity. When norepinephrine stayed high during REM, as it does in some anxiety disorders and in PTSD, the emotional processing that healthy REM sleep accomplishes appeared to be disrupted. The nightmares continued, and the emotional charge of the memories did not diminish. Research using brain imaging technology has made it possible to observe what happens inside the brain between an emotionally charged experience and the next morning. In studies where participants viewed disturbing images and then either slept or remained awake for the same period, those who slept showed measurably reduced amygdala reactivity to the images when they saw them again. The brain had processed the emotional material during sleep, and the result was a softening, not an erasure, of the emotional response. The images were still recognized. The events were still remembered. But the visceral charge that came with them had been reduced. Sleep had worked. The hippocampus is the brain region most involved in forming and consolidating memories. During REM sleep, the hippocampus and amygdala interact in ways that researchers are still working to understand fully. What seems clear is that REM sleep plays an active role in deciding not just what to remember, but how to store what is remembered, and particularly, how much emotional intensity to attach to a memory when it is filed. This process is sometimes called emotional memory consolidation, and it appears to be one of the primary functions of dreaming sleep. Nightmares may represent an intensified version of this process, the brain working overtime on material it has flagged as particularly significant. The continuity hypothesis is another framework researchers use to understand nightmare content. It proposes that dream content is not random, but reflects the preoccupations, concerns, and experiences of waking life. Under this model, people dream about what they are already processing, and the more stressed, anxious, or troubled the waking state, the more threatening the dream content will tend to be. Studies examining the relationship between daytime stress and nighttime dream content consistently find this connection. Nightmares, from this perspective, are the mind's way of continuing to work on problems that were not resolved during waking hours, carrying the emotional work into the sleeping hours to continue what daytime processing could not finish. A notable area of research involves what happens when people ruminate on distressing thoughts immediately before going to sleep. Studies have found that spending time dwelling on intrusive or troubling material in the period just before sleep increases the likelihood of dreaming about threatening events during the night. This connection between pre-sleep mental state and dream content suggests that nightmares are not simply random misfirings. The brain appears to be paying attention to what is emotionally unresolved at the moment sleep begins, and prioritizing that material for nocturnal processing. The nightmare is, in part, a response to what you brought to bed with you. Children experience nightmares far more frequently than adults. Research consistently finds that nightmare frequency is highest in early childhood, typically between the ages of 3 and 6, and then gradually declines across adolescence and into adulthood. One interpretation of this pattern is developmental. Children are encountering the world at a rate that generates enormous amounts of new, uncertain, and sometimes frightening material. The dreaming brain in childhood may be running especially intensive threat simulations because the library of known threats and appropriate responses is still being built. The nightmares of childhood, in this view, are part of the building process. The brain learning what danger looks like and how to respond to it. The question of whether nightmares actually improve threat response in waking life, the central claim of threat simulation theory, has been difficult to test directly. It is not ethically possible to expose people to real threats and measure whether frequent nightmares made them respond better. But some indirect evidence exists. Studies looking at people who live in genuinely dangerous environments, populations affected by ongoing conflict, natural disaster, or serious personal threat, find that nightmare frequency increases in those environments. The brain appears to ramp up threat simulation when real threats are present, as if recognizing that the training is more urgently needed. Whether that training improves outcomes remains an active area of study. During REM sleep, the body undergoes a form of paralysis called rematonia. The muscles of the body, with the exception of those controlling breathing and eye movement, become temporarily unable to move. This paralysis appears to serve a protective function. It prevents the sleeper from physically acting out the content of their dreams. Without rematonia, the brain's threat rehearsals would translate directly into physical behavior. The dreamer running from a predator in the dream would be running in the bedroom. The paralysis keeps the simulation safely contained in the sleeping brain, allowing the rehearsal to proceed without physical risk to the dreamer or anyone nearby. In a rare condition called REM sleep behavior disorder, the normal paralysis of REM sleep fails to engage properly. People with this condition do physically act out their dreams, sometimes striking out, shouting, or moving energetically in their sleep. The content of these enacted dreams is frequently threatening. Being chased, attacked, or engaged in some form of conflict. The condition offers an involuntary window into what the dreaming mind is rehearsing. Studies of REM sleep behavior disorder find that threatening content is among the most common enacted material, consistent with the idea that the sleeping brain spends significant time in threat simulation mode. normally kept safely invisible by the paralysis that holds the body still. Fear extinction is a process by which the brain learns that a previously threatening stimulus is no longer dangerous. It is central to how humans recover from frightening experiences and how trauma therapy works. Research suggests that REM sleep plays a specific role in facilitating fear extinction. During healthy REM sleep, the medial prefrontal cortex engages in theta-frequency rhythmic activity, oscillations at roughly 4 to 12 cycles per second, that appear to strengthen the connections that suppress fear memories. The sleeping brain, during these episodes, is quietly doing the same work that trauma therapy explicitly aims to accomplish, teaching the neural circuits to let go of fear associations that are no longer needed. The relationship between nightmares and post-traumatic stress disorder is one of the most studied areas in sleep science. Estimates suggest that between 70 and 80% of people with PTSD experience recurrent nightmares, many of which replay the traumatic event closely. In PTSD, the normal processing that REM sleep is supposed to accomplish appears stuck. The emotional charge is not being reduced. The fear is not being extinguished. Researchers believe this happens partly because PTSD disrupts the neurochemical conditions that make healthy REM processing possible. Specifically, norepinephrine remains elevated during sleep instead of dropping to the levels needed for the emotional work to proceed. Imagery rehearsal therapy is one of the most well-supported treatments for chronic nightmares, and its mechanism reveals something important about how the brain handles dream content. The therapy asks patients to take a distressing, recurring nightmare and rewrite it, consciously, while awake, choosing a different ending or a different sequence of events. The revised version is then rehearsed repeatedly in the waking state. Studies find that this process can significantly reduce nightmare frequency and distress. What is striking is that the new ending doesn't need to be realistic or even logical. The brain responds to the intentional rehearsal itself. The dreaming mind, it appears, is paying attention to what the waking mind practices and updates its nighttime scenarios accordingly. Lucid dreaming, the state in which a dreamer becomes aware within the dream that they are dreaming, has attracted research interest as a possible intervention for chronic nightmares. The logic is straightforward. If the dreamer can recognize the nightmare as a dream while it is happening, they may be able to redirect its content or reduce its emotional intensity. Small-scale studies have found some support for this approach, particularly in nightmare sufferers who have not responded to other treatments. The ability to observe the dream from within, with the awareness that the threat is simulated, appears to reduce the physiological fear response. Heart rate, arousal, the sense of actual danger, even as the dream continues. The social dimension of nightmares is often overlooked in discussions focused on physical threats. Research examining nightmare content across large populations finds that social threats, exclusion, humiliation, rejection, the loss of important relationships, are among the most common themes, often outnumbering physical threats in adult nightmare reports. This finding fits with an extension of threat simulation theory called social simulation theory, which proposes that dreaming rehearses social scenarios as well as physical ones. Humans are intensely social animals, and the consequences of social failure have historically been serious. Exclusion from a group could mean death for most of human history. The brain running social threat simulations at night may be preparing the social self as carefully as it prepares the physical one. We have spent 25 facts looking at nightmares from the outside. Their timing, their content, their neural architecture, their evolutionary origins. What has emerged is a pattern. The dreaming brain is not passive. It is running scenarios with purpose, rehearsing threats the waking self hopes never to face, and processing emotional material in a neurochemical window that softens what it reviews. The central question tonight is whether this activity is a defense mechanism, and the evidence so far suggests not whether, but how. The second arc begins where this one left off. Not with what nightmares are made of, but with what they do to the brain that experiences them, and what happens when they stop working the way they were designed to. Let the facts settle for a moment. You don't need to hold them. Breathe in slowly, and as you exhale, let your awareness move gently downward. Notice the weight of your body, the places where you are supported. There is nothing to figure out right now. No problem to solve. The brain that runs these midnight simulations is the same brain resting now, and it knows exactly what it is doing. Let your breathing slow. Let your muscles soften, one by one. You are safe here. Nothing is required of you. Simply rest. If nightmares are protective, a natural question follows. What makes some people's nightmares more frequent than others? Researchers have identified several reliable predictors. Anxiety, depression, and chronic stress all correlate with higher nightmare frequency. Certain medications, particularly those affecting serotonin and norepinephrine systems, including some antidepressants, can increase the vividness and frequency of dreams. Irregular sleep schedules disrupt the REM architecture that healthy emotional processing requires. And early adversity, significant stress or trauma in childhood, appears to create lasting changes in how the brain's fear systems are calibrated, increasing nightmare susceptibility across the entire lifespan. A large-scale genetic study published in Translational Psychiatry examined the heritable component of nightmare frequency across tens of thousands of individuals. The researchers found that heritability for nightmare frequency was estimated at around 5%. Suggesting that genetic factors play a modest but real role. More striking were the genetic correlations they found. The genes associated with frequent nightmares overlap substantially with the genetic risk factors for anxiety, insomnia, and depression. The finding suggests that nightmares are not simply a separate sleep phenomenon, but are biologically entangled with the broader architecture of emotional regulation, sharing deep roots with the systems that govern mood and stress response. Women report more frequent nightmares than men across nearly all age groups and cultural contexts. Research finds that lifetime prevalence of nightmares among women is meaningfully higher than among men, though this gap tends to narrow with age. Several explanations have been proposed. Women may be more likely to recall and report dreams in general. There may also be hormonal influences on REM architecture across the menstrual cycle. Some research populations with higher average anxiety tend to show higher nightmare frequencies. The gap is real and consistent, even if its precise origins remain under study. The brain does not dream in isolation from the body. During nightmares, the physiological changes associated with the fear response occur in measurable ways. Even though the body is physically paralyzed by rematonia, heart rate increases, breathing becomes irregular, skin conductance, a measure of subtle sweating related to arousal, rises. These physiological responses suggest that the brain is not merely generating images during a nightmare. It is running the entire emergency system. The visual simulation, the emotional processing, the autonomic nervous system, all simultaneously. The body, even in sleep, responds to what the brain believes is happening. Sleep architecture changes significantly under stress, and these changes have consequences for nightmare frequency. Under chronic stress, the body's stress hormones, cortisol and norepinephrine, remain elevated longer than usual, including during sleep. Elevated norepinephrine during REM specifically disrupts the neurochemical conditions that allow emotional processing to proceed. The result is a kind of paradox. The brain is under more stress and therefore needs the emotional processing that healthy REM sleep provides. But the stress itself is degrading the quality of that REM sleep, making the processing less effective. Nightmares may intensify under these conditions, not because the brain is failing, but because it is working harder against increasing interference. The concept of affect regulation during sleep, the idea that the brain actively manages emotional states overnight, has gained traction in sleep science over the past 2 decades. A review published in Sleep Medicine in late 2024 examined the evidence for REM sleep as a transdiagnostic feature of psychiatric disorders involving emotion dysregulation. Across conditions including PTSD, depression, anxiety disorders, and borderline personality disorder, abnormalities in REM sleep appear with remarkable consistency. This pattern supports the view that REM sleep is a dedicated system for maintaining emotional equilibrium, and that nightmares are one of the system's primary tools. There is a measurable difference in how people who experience frequent nightmares process emotional information while awake. Research using brain imaging has found that frequent nightmare sufferers show elevated amygdala reactivity to negative emotional stimuli during waking hours compared to those who sleep without significant nightmare disturbance. The finding suggests that the relationship between nightmares and daytime emotional regulation is bidirectional. Heightened waking emotional reactivity may contribute to nightmare frequency, but nightmare frequency may also reflect a brain that is processing emotional material less efficiently during sleep, leaving more of that work undone and more emotional charge available during the waking day. The brain's threat detection system operates across a wide spectrum of danger, not only predators and physical violence, but social rejection, loss, failure, and the kinds of invisible threats that occupy most of modern human anxiety. Research examining nightmare themes in contemporary Western populations finds that themes of being late, of embarrassment, of failure at work or school, and of relationship conflict are among the most frequently reported. These are not the threats our ancestors faced in open savanna, but the brain processes them with the same systems. The nightmare machinery, evolved to handle predation, has been repurposed to handle performance reviews. The tools are ancient. The scenarios are new. The way a nightmare ends matters. Research suggests that nightmares in which the dreaming self successfully resolves or escapes the threatening situation may function differently from nightmares that end in failure or awakening. Some evidence indicates that resolution within the dream, finding safety, overcoming the threat, reaching a point of relative security, may be associated with more effective emotional processing. The brain may benefit most from scenarios it can complete. This may be part of why therapy approaches that involve rewriting nightmares, constructing different endings, show promise. The brain responds to resolution, even when that resolution is introduced through deliberate imagination rather than spontaneous dreaming. During periods of collective stress, widespread social uncertainty, pandemic, conflict, natural disaster, nightmare frequency rises measurably across populations. A multi-country study examining dream content before and during the early period of a major global health crisis found that nightmare frequency nearly doubled in the affected populations. The content of these elevated nightmares reflected the specific threats of the situation: fear of illness, of loss, of isolation. The brain, responding to a genuine shift in the threat environment, increased the intensity of its nighttime rehearsals. This population-level response is consistent with the idea that the threat simulation system is sensitive to real-world danger and ramps up when the environment genuinely warrants it. One of the more notable findings in nightmare research involves what happens in the brain in the moments just before awakening from a nightmare. Studies using high-density brain recording technology have found that a distinctive pattern of electrical activity, sometimes described as a slow oscillation, followed by a burst of faster activity, occurs immediately before the arousal that ends a nightmare. This pattern resembles the neural signature associated with sudden emotion in waking life. The brain appears to be experiencing something close to genuine alarm, not metaphorically, but in terms of the actual electrical and chemical events unfolding in the neural tissue. The nightmare wakes you because the brain's emergency system has genuinely fired. Context matters in how the brain encodes fear memories. Research on fear conditioning and fear extinction has established that memories are not stored as fixed recordings. They are reconstructed each time they are recalled, and the conditions during recall influence how the memory is stored afterward, a process called reconsolidation. REM sleep appears to interact with this reconsolidation process. When emotional memories are replayed during dreaming sleep, they may be reconsolidated in the lower norepinephrine environment of REM, effectively being refiled with reduced emotional charge. The nightmare may be part of how the brain accesses and then gently edits the files it keeps on frightening experiences. The locus coeruleus is a small cluster of neurons in the brainstem that serves as the brain's primary source of norepinephrine. During waking, it fires regularly, maintaining arousal and alerting the brain to significant events. During NREM sleep, its activity decreases. During REM sleep, it goes quieter still, reaching its lowest point in the entire 24-hour cycle. This near silencing creates the neurochemical conditions that allow emotional processing to proceed. Researchers have proposed that this silence is essential, that the locus coeruleus must quiet for the fear extinction work of REM to proceed. There is something called the day residue effect in dream research, the consistent finding that events from the previous day appear in dreams that same night, and then again several nights later. This later recurrence is sometimes called the dream lag effect, thought to reflect memory consolidation. Material is first processed the night after the experience, then returns for deeper consolidation a few nights later. Distressing experiences tend to generate heightened nightmare activity in the nights immediately following them, and the brain appears to use these subsequent nights to process what the first night could not fully resolve. By the time we have reached 40 facts, a picture has emerged that is different from the way nightmares are usually described. They are not symptoms of fragility. They are not signs of psychological damage. They are, in a measurable biological sense, the brain doing a particular kind of work: simulation, rehearsal, emotional processing, and the gradual reduction of fear's charge. The question the next section follows is quieter. Not what nightmares are for, but what they feel like from the inside, and why the brain designed the experience to be so vivid, so real, and so difficult to dismiss. If the science tonight has given something to the part of you that has ever woken afraid and wondered what it means, a quiet like, a gentle subscribe. It helps another person find their way to this place. One quiet tap, one sleepy soul at a time. The vividness of nightmare imagery is not accidental. During REM sleep, the brain's visual processing centers become highly active, more active, in some measures, than during ordinary waking. The brain generates the visual content of dreams internally, without input from the eyes, and the result can be extraordinarily detailed. Colors appear saturated. Spatial environments feel real and navigable. The faces of people in dreams are recognizable. This visual richness appears to serve the simulation function. A threat rehearsal that feels abstract or low fidelity may not activate the neural pathways with the same intensity as one that feels genuinely real. The brain builds nightmares in high resolution because the training benefits from it. The sense of being unable to move, unable to scream, unable to call for help, experiences many people describe inside nightmares, has a neurological basis. During REM sleep, the motor cortex receives inhibitory signals that block voluntary movement. The dreaming brain generates the intention to move, but the signal is intercepted before it reaches the muscles. In some nightmares, the dreamer experiences this interception directly, feeling paralyzed within the dream itself. This experience of blocked agency is frightening, but it is also the brain's safety mechanism operating correctly. The fear of being unable to move is, in a biological sense, the sensation of being protected. Recurring nightmares, the same scenario replayed across many nights, sometimes across years, are among the most distressing experiences that nightmare sufferers report. Researchers interpret recurrence in different ways. One view is that recurring nightmares represent a processing failure. The brain returning again and again to material it has not yet succeeded in filing with reduced emotional charge. Another view is that recurrence reflects a particularly persistent real-world concern. The brain recognizing that a threat is still present and that the rehearsal should continue. Both interpretations suggest that the brain is not being arbitrarily cruel. It is returning to the same material because that material has not yet been resolved to the system's satisfaction. The brain does not generate threat simulations only from personal experience. Cultural material, stories, films, images, shared symbols of danger can also populate dream content. Research examining nightmare themes across populations finds that cultural narratives about danger influence what people dream about. Children who have been exposed to particular kinds of frightening stories or images show elevated rates of those themes in their nightmare content. The dreaming brain, it appears, does not distinguish sharply between personally experienced threats and culturally transmitted ones. Both enter the simulation library. Both become available for nighttime rehearsal. The brain treats stories about danger with something approaching the same seriousness as actual memories of it. The emotional tone of the waking day reliably predicts the emotional content of the following night's dreams. Research across multiple studies finds that negative mood during the day, anxiety, stress, irritability, sadness, increases the probability of negative dream content that night. Positive emotional states during the day are associated, though less strongly, with more positive dream content. This relationship has practical implications. Managing the emotional quality of the waking day, not through avoidance, but through genuine engagement with what is troubling, may influence what the sleeping brain has to work with. The Dream Lab, in other words, runs on the material you provide it. The hippocampus, during REM sleep, shows a distinctive pattern of activity that researchers have associated with memory replay. Sequences of neural firing that occurred during the day appear to be replayed during sleep, sometimes in compressed form, sometimes in reverse. For emotional memories, this replay process may be where the emotional tag on the memory is adjusted. The hippocampus, working alongside the amygdala and the medial prefrontal cortex, appears to be sorting through the day's emotional experiences, deciding what to retain, what to reduce, and how to integrate new material into the existing structure of long-term emotional memory. Nightmares may represent replay of material the system has flagged as most in need of this sorting. Sleep deprivation reliably worsens emotional regulation during waking hours, and the mechanism involves the same amygdala pathways implicated in nightmare processing. Studies of sleep-deprived individuals using brain imaging find that the amygdala becomes significantly more reactive to negative stimuli after insufficient sleep, and that its functional connection to the prefrontal cortex becomes weaker. The regulatory relationship between these two regions degrades. The part of the brain that would normally say this is not as dangerous as it feels becomes less able to deliver that message. Getting less REM sleep, whether through total sleep deprivation or through disrupted sleep architecture, leaves more emotional charge unprocessed and more material available to become nightmare content. There is a phenomenon researchers sometimes describe as emotional memory specificity. The brain retains the factual content of experiences more reliably than the emotional intensity attached to those facts. Under healthy conditions, with adequate REM sleep, a person can remember what happened without being overwhelmed by the original emotional force of the experience. The memory is intact. The charge is reduced. This is the outcome that nightmares, when they function as intended, are working toward. The person who wakes from a nightmare may find, over subsequent nights, that same material gradually losing its force. The brain completing the work that the nightmare began. The experience of waking from a nightmare and feeling disoriented, unsure for a moment whether the threat was real, reveals how convincingly the brain constructs its simulations. The neural experience of the nightmare is processed, at the time, as a real event. The emotional systems respond accordingly. The heart beats faster because the danger detection system has concluded that danger is present. It is only the return of waking consciousness, the recognition of the familiar bedroom, the actual body, the absence of the threat, that resolves the question. The brain cannot fully distinguish simulated from real threat in the moment. This may be precisely the point. Halfway through tonight's journey, the arc of the answer has become clearer. We began with the question of whether nightmares are a defense mechanism. And 50 facts later, the evidence has moved substantially in one direction. The brain maintains a system, active during sleep, that rehearses threat scenarios with high emotional fidelity and processes distressing memories in conditions designed to reduce their charge. This is not the description of a malfunction. It is a system doing exactly what it was built to do. The second half follows the question the first half opened. What does it feel like when this system works? And what happens when it doesn't? You are at the midpoint of the night. Breathe in slowly. And exhale. The brain you carry has been running these rehearsals your entire life, long before you had words for what they were. There is something quietly steady about that. The part of you that generates these dreams is not afraid of the dark. It works there. It is most itself there. Let your body sink a little further into stillness. The rehearsal is done for tonight. There is nothing left to prepare for. Only the softness of rest. Only this. The theta rhythm is a pattern of electrical brain activity oscillating at roughly 4 to 8 cycles per second. It appears during drowsiness, light, sleep, and REM, and has been associated with memory processing and emotional regulation. During REM sleep, theta oscillations in the medial prefrontal cortex appear to coordinate activity between the prefrontal cortex and the amygdala in ways that facilitate fear extinction. The brain's internal clock, running at this slow and steady rhythm, is doing something specific with emotional memory during every REM cycle. The term extinction learning refers to the process by which the brain learns that something previously associated with fear is no longer threatening. It is not forgetting. The original fear memory remains. What changes is the addition of a competing memory. This thing that once meant danger no longer does. Healthy REM sleep appears to support this process by providing conditions in which the prefrontal cortex can strengthen its inhibitory connections to the amygdala's fear circuits. People with anxiety disorders and PTSD often show deficits in extinction learning, and these deficits are associated with abnormalities in REM sleep. The average adult experiences 4 to 6 REM periods per night, with each successive period typically longer than the last. The final REM period, the one closest to natural waking, can last 40 minutes or more. This is where the most vivid and emotionally intense dreaming tends to occur. People who cut sleep short are disproportionately cutting this final, longest period. The emotional maintenance work of that final REM is among the most significant of the night, and it is the first sacrificed when sleep is truncated. The amygdala's response to a nightmare does not vanish the moment the dreamer wakes. Research tracking mood following nightmare episodes finds that the elevated emotional state can persist into the morning, influencing how the waking brain responds to ordinary stimuli. People who have had disturbing nightmares wake into a morning already primed for negative emotional reactivity. This carryover may simply reflect the normal continuation of the emotional system's activity across the sleep-wake boundary, an arousal that was physiologically real, continuing to influence the day it opened into. There is evidence that the brain's threat simulation system is selective about what it rehearses. Analysis of nightmare content across large samples finds that dreams weight certain categories of threat more heavily, particularly those that were evolutionarily significant. Interpersonal threats, physical attack, being pursued, falling. These appear far more often than technically dangerous modern scenarios. People rarely dream of car accidents, financial ruin, or technology failure with the same visceral intensity as being chased. The ancient library runs on older fears. The idea that nightmares have therapeutic potential, not as things to be endured, but as material to be worked with, has gained scientific credibility over the past 2 decades. Nightmare-focused therapies that ask patients to engage consciously with their dream content have shown measurable reductions in nightmare frequency and distress. The processing the nightmare attempts during sleep can be continued and assisted while awake. The dreaming brain and the waking mind are not opposites. They are parts of the same processing system, and they can cooperate. The brain during REM sleep shows patterns of connectivity that differ markedly from both waking and NREM sleep. Regions that do not typically communicate during waking become linked during dreaming. Emotional centers connect to visual areas. Memory systems engage with sensory processing regions. This unusual connectivity may be part of how the brain integrates emotionally significant experiences into broader meaning structures, finding connections that the more compartmentalized waking brain might miss. The surreal quality of dreams, the unexpected juxtapositions, the sudden contextual shifts may reflect this unusual network configuration rather than randomness. Research on nightmare disorder, the clinical condition defined by frequent, distressing nightmares that impair daytime functioning, finds that it is substantially underreported and undertreated. Surveys find that only roughly a third of people who experience frequent distressing nightmares ever mention them to a healthcare provider. In reality, nightmare disorder has well-supported treatment options, including imagery rehearsal therapy, which has demonstrated effectiveness in multiple controlled trials. The reluctance to seek help reflects a cultural misunderstanding of what nightmares are and what they do. The experience of witnessing someone else's fear, reading about it, watching it on screen, hearing it described, can find its way into nightmare content. The brain appears to process vicarious threat experiences in ways that share mechanisms with direct threat exposure. Studies examining emotional processing of frightening media before sleep find increased rates of disturbing dream content in the nights following. The emotional material the dreaming brain has access to is not limited to personal experience. It includes what has been absorbed through attention. The brain does not always distinguish between what happened to you and what you witnessed. One of the more elegant findings in nightmare science concerns what happens when nightmares are successfully treated. When nightmare frequency decreases through therapy, medication, or improved sleep, the reduction is often accompanied by improvements in daytime emotional regulation and mood. If nightmares reflect a brain struggling to process emotional material, and if treatment allows that processing to proceed more efficiently, the benefits should appear not only in the nights, but in the days. Better emotional processing during sleep means more fully processed emotions while awake. The two are not separate. They are the same system, operating in different states. The brain's ability to generate emotionally coherent narratives appears to be active during dreaming. Nightmares are not just collections of threatening images. They tend to have a structure. A threat appears. The dreamer responds. Things escalate. The situation reaches a resolution or breaking point. This narrative architecture mirrors the structure of waking emotional memory. Events that matter are stored not as isolated snapshots, but as sequences. What happened? What came after? How it ended? The nightmare may be practicing narrative encoding as well as threat response, building the story structure that memory will use to hold the experience. Some researchers have proposed that nightmares involving being chased or attacked serve a specific neural function beyond general threat rehearsal. They may help calibrate the subjective experience of fear itself. By regularly generating intense fear in a controlled setting, the paralyzed, sleeping body, the brain may be setting the baseline for what fear feels like and how much various situations warrant. This calibration argument suggests that nightmares help regulate the threshold of fear response. A brain that never runs fear scenarios may be less accurately calibrated when real fear is needed. The nightmare is the instrument the brain uses to keep its fear system properly tuned. The insula is a brain region associated with interoception, the ability to sense internal body states. It is also heavily involved in the subjective experience of emotion, including fear. Research finds elevated insular activity during REM sleep, and particularly during nightmares. This suggests the emotional experience of a nightmare is not purely visual or cognitive. It is felt in the body, or at least in the brain's representation of the body's internal state. The racing heart, the tightness in the chest, the cold that moves up the spine. These sensations during a nightmare are generated by the brain's interoceptive systems, running alongside the visual content. The relationship between creative capacity and nightmare frequency is a curious one. Research has noted that individuals with higher levels of creativity and imagination tend to report more vivid and frequent dreams, including nightmares. The brain regions associated with imaginative thinking, generating novel scenarios, holding multiple possibilities simultaneously, are also engaged during dreaming. This overlap suggests that the dream generation system and the creative imagination system may share neural resources. The same capacity that allows a mind to envision possibilities that don't yet exist also allows it to construct threats that haven't yet occurred. Imagination and nightmare share an architecture. At 65 facts, the picture has become layered. The brain that runs nightmares is the same brain that consolidates memory, regulates emotion, and maintains the neurochemical balance needed to face the following day. Nightmares are not a separate function that occasionally disrupts these processes. They are part of the same integrated maintenance system, a nighttime preparation service that uses emotional vividness to do work that quiet sleep alone could not accomplish. The distress of a nightmare is not waste. It is signal. It is the brain communicating the intensity of what it is processing. The quality of social relationships influences nightmare frequency in measurable ways. Research consistently finds that loneliness, the subjective experience of feeling socially disconnected, is associated with higher rates of disturbing dreams. One interpretation is that loneliness registers in the brain's threat detection systems as a genuine form of danger, consistent with the evolutionary understanding that social disconnection historically meant increased vulnerability. The dreaming brain of a lonely person may be running elevated threat simulations because the waking situation it is monitoring has been assessed as genuinely more dangerous. The nightmare responds not only to daily events, but to the underlying conditions of the life being lived. Eye movement, desensitization, and reprocessing, commonly known as EMDR, is a therapy for trauma that involves recalling distressing material while following a bilateral stimulus, such as the therapist's moving finger, with the eyes. The mechanism is not fully understood, but some researchers have proposed that the bilateral eye movement may mimic a process that occurs naturally during REM sleep. Under this model, EMDR may be replicating the neural conditions of REM processing to treat trauma therapeutically. The same movement of the eyes that happens during dreaming may, in the therapy room, be helping to process what the nightmare was failing to resolve. The amygdala's involvement in nightmares extends to the encoding of fear memories in the first place. When something frightening happens in waking life, the amygdala acts as an emotional amplifier, strengthening the encoding of the memory proportional to its perceived threat level. Highly frightening experiences are encoded more vividly and durably than routine ones. This is adaptive. The brain wants to remember things that nearly harmed it. But the most frightening experiences also generate the most vivid nightmare material, which must then be processed by the same system that created the intense encoding. The cycle is demanding, but it is the brain following its own logic. The experience of waking from a nightmare and then being unable to return to sleep is among the most commonly reported consequences of nightmare disorder. The activated stress system takes time to settle. Norepinephrine, elevated by the arousal, does not drop immediately. Heart rate remains elevated. The body, brought to a state of alert, does not return to sleep conditions simply because the dreamer knows the threat was not real. This post-nightmare insomnia is among the most directly harmful consequences, not because of the nightmare itself, but because of the subsequent sleep disruption. Addressing nightmare frequency typically reduces this secondary insomnia as well. There is something quietly compassionate about the brain's design once you understand what nightmares are doing. The brain is not tormenting the sleeper. It is preparing the sleeper, using the hours when the body is still and the waking mind is quiet to do maintenance work that the complexity of waking life does not allow. The vividness is not cruelty. It is engineering. The fear is not meaningless. It is information, being processed in the only way that information of that weight can be processed: by being felt, examined, and gradually filed differently. The nightmare is, in this sense, an act of care. Nightmares that occur early in sleep, during NREM rather than REM, are called sleep terrors, and they are neurologically distinct from REM nightmares. Sleep terrors involve sudden arousal and apparent distress, but the sleeper typically does not recall the content afterward. REM nightmares, by contrast, occur later and are vividly remembered. The two phenomena involve different brain states and appear to serve different functions. Sleep terrors may represent a different kind of arousal response, one associated with stage transitions, rather than the narrative emotional processing that characterizes REM dreaming. The concept of hyperarousal, a state of chronically elevated physiological alertness, is central to understanding why nightmares worsen under stress and trauma. People in hyperarousal states show elevated baseline activity in threat detection systems even during ordinary waking moments. This elevated baseline follows them into sleep. The sleeping brain of a hyper-aroused person enters REM with its threat detection system already running at higher intensity, and the simulations it generates reflect that intensity. Nightmares in people with anxiety disorders, or PTSD, are the output of a system that is running hotter than it should, and that heat makes the output more intense. Research has examined whether people who experience frequent nightmares are better at recognizing emotional states in others during waking hours. Some evidence suggests a modest association, that people with higher nightmare frequency show elevated sensitivity to expressions of fear and distress in other faces. The relationship is not large and not definitively established, but it is consistent with the idea that the dreaming brain's intensive work on emotional threat recognition may have some expression in the waking social world. A brain that practices reading threat in simulation may become somewhat more attuned to signals of distress in real faces. The final phase of a nightmare, the seconds immediately before awakening, has attracted specific scientific attention. Studies using continuous physiological monitoring find that the arousal ending a nightmare is not instantaneous. It appears to build across a brief period, as if the brain is assessing the simulation's intensity and eventually reaching a threshold at which waking becomes the appropriate response. The decision to wake appears to involve the same executive systems that govern attention during waking life. The brain monitors its own dream state, assesses when the simulation has become too intense to remain contained, and activates the arousal system to bring the dreamer back. The brain that builds nightmares is not separate from the brain that builds hope and reaches toward connection. It is the same brain, doing different work in different states. What these facts have slowly revealed is that the nighttime architecture of fear is part of a larger design. The dream laboratory runs because the waking life needs what it produces: processed emotion, calibrated threat response, the gradual softening of what once overwhelmed. The remaining facts carry a different quality. They move from the mechanism to the meaning, from what the brain does in the dark to what it is reaching toward. Let everything you have carried tonight become a little lighter. Breathe in and breathe out slowly. The brain that built every nightmare you have ever had was reaching toward something. A morning that felt a little safer than the night. It has been doing this work your entire life. In the quiet hours when you didn't know it was working, let your body soften. Let your breath move without effort. You are at the edge of something still and warm. Let it hold you. The brain's most fundamental job is to keep you alive. Everything else follows from that. The systems that generate fear, that run threat simulations, that wake you gasping from a dream that felt real. All of it serves this one underlying purpose. Once that is understood, the nightmare becomes something different. Not an enemy, not a failure, a guard, an ancient, sometimes imperfect, deeply committed guardian, doing its work in the only way it knows how. Sleep is not passive. The body rests, and the mind works. In the hours the world cannot see, the brain is reviewing what mattered, softening what hurt, and preparing the self for what comes next. The nightmare is part of this quiet labor, vivid and frightening. Yes, but never without direction. It moves towards something. It has always been moving towards something. The fact that nightmares ease over time, that memories which once produced vivid, disturbing dreams gradually lose their power to do so, tells us something about the endpoint the brain is working toward. It is not building permanent fear. It is building toward a place where the fear has been processed enough to be held differently. The nightmare is not the destination. It is the path. And most paths, if you follow them long enough, lead somewhere quieter. The experience of waking from a nightmare and finding the room familiar, the body intact, the threat absent. This moment of recognition is its own kind of gift. The brain has just run a scenario of danger and brought you back from it. You are safe in a specific way. Not just safe because nothing is wrong, but safe because the brain has reminded you what unsafe feels like, and then returned you to this. The contrast matters. Safety after a nightmare is felt. Every nightmare carries within it the moment that ends it. The arousal, the breath, the room. No nightmare lasts forever. Not because the brain runs out of material, but because the brain itself calls the session to a close. Even in its most frightening work, it is protecting the sleeper from too much. There is a built-in mercy in the architecture. The nightmare ends because the brain decides it should end. The sleeping body is the safest place the brain has ever known for doing this work. The world cannot interrupt. The consequences of the simulation are contained. The fear is real, but the threat is not. This is the most extraordinary thing about the dream laboratory. It runs experiments that would be unacceptably dangerous in waking life. In a space where the cost of the experiment is only a difficult night, the brain chose this space deliberately. It could not do this work anywhere else. There are people alive today who have not had nightmares in years, not because they have nothing difficult to process, but because they have slept well, processed consistently, and built the kind of emotional equilibrium that makes the nightmare laboratory less urgently needed. This is not the absence of a defense mechanism. It is the defense mechanism working so well that it no longer needs to sound the alarm. A well-maintained system runs quietly. The goal of the nightmare is its own obsolescence. Dreams of flying, of impossible spaces, of people long gone. The brain does not limit itself to threat in its nocturnal work. The same dream generation system that builds nightmares also builds wonder. The same connectivity that joins fear to memory joins joy to meaning. The dreaming brain is wide. It holds everything the waking life has accumulated, the frightening and the beautiful, the unresolved and the beloved. The nightmare is only one room in a much larger house. The science of nightmares is younger than the nightmares themselves. For most of human existence, no one knew why the sleeping mind constructed these frightening architectures. They were explained with spirits, with gods, with messages from beyond the waking world. Now we know something more specific, and in some ways, more moving. The brain builds them because it cares what happens to you. It is doing, in the only hours it has, the maintenance work that keeps the self intact. You do not have to understand a nightmare to benefit from it. The brain runs its processing whether or not the waking mind makes sense of the content. The work happens in the neural tissue, in the firing and softening of circuits, in the theta rhythms moving through the medial prefrontal cortex, in the amygdala settling toward a quieter morning. The meaning of the dream is secondary. What matters is that the brain had the dream, and that it kept going until it was done. The brain that has spent years processing through nightmares is a brain that has been quietly strengthening. Each rehearsal has refined the threat detection system. Each night of REM processing has softened what once felt unspeakable. The accumulation is not visible in the morning. It doesn't announce itself. But the person who wakes on the other side of years of difficult dreams has been changed by them, in ways that mostly run toward resilience. There is a quality to the morning after a difficult nightmare that is different from other mornings. The contrast is alive. The light in the room seems specific. The ordinary sounds of the world carry their own kind of presence. The brain has just been reminded, with vivid precision, of what danger feels like. And so the absence of danger carries more weight than it usually does. Safety is not neutral after a nightmare. It is felt. The word protection has been used throughout tonight in a particular way. Not protection from difficulty. The nightmare does not prevent hard things from happening. Protection through processing. The nightmare ensures that hard things that have already happened do not stay harder than they need to. It is not a shield between you and the world. It is a system that helps you carry what the world gives you without being permanently defined by it. Every night, across the sleeping population of the Earth, billions of brains are running these simulations. Right now, in this moment, some person in some time zone is waking from a dream with their heart beating hard. Some person is returning to sleep with the fear already fading. Some brain is completing a piece of emotional maintenance work that began days ago and tonight reached resolution. The scale of this labor, invisible, collective, continuous, is extraordinary to contemplate. The dreaming mind of the world never stops working. The brain does not need you to remember the nightmare for it to have done its work. Most dream content is forgotten within minutes of waking. A feature, not a flaw. The forgetting is likely part of the design. The emotional processing that took place during the dream does not require the conscious mind to retain the specifics. The circuits have already been updated. The charge has already been reduced. The memory of the nightmare fading is not the work being lost. It is the work being completed. The relationship between nightmares and meaning is one that philosophy and therapy share. Many therapeutic approaches invite dreamers to engage with nightmare content, not as a problem to be eliminated, but as a communication to be understood. What the nightmare was about, the themes it returned to, the quality of the fear, can sometimes illuminate what the waking self has not yet fully acknowledged. The nightmare is not always a message, but sometimes it is. And listening to it rarely makes things worse. The brain's commitment to this nocturnal work is constant across a lifetime. The same basic processes: REM cycling, theta oscillations, amygdala processing, prefrontal modulation, operate every night, from infancy through old age. The specific content of nightmares changes as life changes. The mechanism does not. It was there when you were a child, running scenarios you couldn't name. It is here now. It will be there at every difficult chapter the future holds. Some of the best slept, most emotionally regulated people have rich and active dream lives, including occasionally disturbing ones. The absence of nightmares is not always a sign of psychological health. It can reflect sleep too shallow for REM, emotional numbness, or medications that suppress dream activity. A brain that is dreaming richly, even troublingly, may be a brain engaged with its own emotional life. The nightmare, in this light, is not failure. It is participation. The brain never fully explains itself. The nightmare leaves no footnotes. It does not come with a key that unlocks its content, or a certificate confirming that the processing was successfully completed. It arrives, and it ends, and it fades, leaving the sleeper with fragments, sometimes disturbing, sometimes strange, sometimes oddly beautiful. This incompleteness is not a flaw in the system. The brain was not designed to report its own maintenance work. It was designed to do the work. The not knowing is part of the design. The word for nightmare, in many languages, derives from the idea of something sitting on the chest, a weight, a presence in the night. This imagery captures something real. The nightmare is felt in the body. It presses, and then it lifts. The pressure and the release are both the brain doing its work, loading the emotional material fully, then letting it go. The relief that follows a nightmare is not accidental. It is the system completing its cycle. There is something quietly extraordinary about lying in this darkness tonight, knowing what is happening in the brain on the other side of waking. The theta rhythms will begin. The amygdala will engage. The brain will run its scenarios. And at some point, the work of tonight will be done, and the morning will begin lighter than the night. This happens for you. Every night. Without being asked. Nightmares will come again. Not because something is wrong, but because life continues to offer difficult material. The brain that builds bad dreams in the night is the brain that carries you through the difficult days that generate them. The two are inseparable. The dreaming mind and the waking mind are not opponents. They are partners, working different shifts toward the same end. The softness you feel right now, the loosening of the day, the heaviness of the body, the way thought is beginning to blur at its edges. This is the beginning of the same process. The brain is preparing to do its work. You do not need to guide it. You do not need to monitor it. Simply allow it. Simply arrive at sleep the way you arrive here, without agenda, without effort, without needing to know what happens next. Whatever the brain finds tonight, it will handle. That is what it was built for. Every nightmare you have ever survived is evidence of this. Every morning you have opened your eyes and found yourself intact. The work done. The night behind you is the proof the brain has been quietly compiling your entire life. You are not fragile. You are the result of 10,000 nights of this same quiet labor. You are here because the brain did not stop. The answer to tonight's central question is this. Yes, the nightmare is a defense mechanism, but the deeper truth is warmer than any mechanism can hold. The brain builds frightening dreams because it cares about what happens to you in the waking world. The fear in the dream is not the enemy. It is the sleeping mind's commitment to the self that must face tomorrow. It says, I have been working all night to make you more ready. Now, rest. The work is done. 100 facts ago, we were asking whether the nightmare was a defense mechanism. Now the question has become almost too small for what we found inside it. We followed the amygdala through the dark, fully active, engaged, running the scenarios that the waking self cannot rehearse in daylight. We watched the locus coeruleus go quiet, the norepinephrine drop, the prefrontal cortex gently moderating what gets felt and what gets softened. What began as a question about fear became an answer about care. The brain that builds the nightmare and the brain that carries you through the difficult day are the same brain, working different hours toward the same morning. The nightmare is a rehearsal space, not a verdict. What you dream about in the frightening hours is the brain deciding that you matter enough to prepare. Carry that knowledge into sleep tonight. Let your breath arrive on its own. You don't have to hold anything now. The dreaming brain that has accompanied you your entire life is here. It has been in every difficult night you have ever come through. It was there when you were young, and the darkness felt uncertain. It is here now, in this room, in this body that is already beginning to soften towards sleep. Let your entire being dissolve into the quiet that comes before dreaming, the last moment of awareness before the brain takes over and begins its gentle, faithful work. You don't need to stay awake for it. You never did. Let go. If tonight's science gave something to the part of you that has ever woken afraid and wondered if it meant something was wrong, a quiet like, a gentle share with someone who might need it. It helps another person find their way to this place. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight. You can allow these thoughts of nightmares and dreaming brains and midnight rehearsals to fade now, like smoke thinning in the cool air after a fire has gone out, leaving only the quiet warmth behind. Let your breathing deepen. Let your body feel heavier, as if the darkness itself has a gentle gravity pulling you safely downward into rest. If sleep comes, let it carry you like water finding the lowest place, smoothly, inevitably, into a place where time and weight no longer matter. Dream science to fall asleep, to returns to the sleeping brain from a different angle in the next hour, the side that doesn't run threat rehearsals, but still never stops working. What it does with the quiet dreams, the ones that don't wake you, is a question this hour didn't have time to reach. That hour is waiting whenever you are ready. But if your eyes are closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the dreaming brain will still be there. But tonight belongs to stillness. Rest well, worried one. And remember, the brain that builds the nightmare is the brain that carries you through the day it was rehearsing for, where curiosity ends and sleep begins. Good night.